Hey, what's up? It's been a while, but let's not think that I've just been too lazy to make new videos, okay? But anyway, we've got geometry nodes in Blender now, which is awesome. Unfortunately, it means that they kind of pushed the particle nodes into the future somewhere, which is a shame because I really liked the particle stuff. But we got new toys to play with in Blender, new procedural toys, so I think it's okay. I made this short motion graphics demo with the geometry nodes, and I'm finally starting to figure out the attribute workflow, how to do things with them. It's quite different from anything I've used in the past. And in this video I'll show you how to make the basic setup with a grid of floating cubes and how to control those floating cubes with a controller object. I won't cover every single detail of how I made this animation, but this tutorial will give you a good starting point to get to know geometry nodes a little bit and to understand some of the attribute stuff. The geometry nodes are now actually being worked on more for the scattering workflows and set dressing and stuff like that. But I'm more interested in motion graphics, so I'll probably be using it more for that. But anyway, let's get straight into it. So first things first, to play with the geometry nodes, you should go to builder.blender.org and then download this latest 2.92 alpha build and then open that up. So we have the default scene here. We're actually gonna save the default cube and set it aside here because we're gonna need it later. And then we're gonna add a plane and make it bigger. And then just right click to add a bunch of subdivisions. Let's say we add like 40 of them here. Something like this. And then we can go back to object mode and start to work with the geometry nodes. So geometry nodes is a modifier. So you just go here to the modifiers tab, add modifier, and down here you have geometry nodes. So just add this. And it automatically created a node group for us. And we can see that by dragging a new panel for us from up here. And we'll change this upper one to geometry node editor here. And this editor is where all the fun things happen. As you can see, we have the basic node group here. We have an input and we have an output, and all the geometry just goes from the input straight to the output and nothing happens. We still have a basic plane here. So let's just do a couple basic things so you can get a feel for how this works. So you can press Shift A to add nodes, and from the geometry category let's add transform, and let's drop it here in the middle. So this just takes the geometry and makes some translations and then outputs the translated geometry. So if we move these sliders here, you can see that the object is moving around in the scene like this. And let's also add another node after this transform node. So Shift A, mesh, let's say subdivision surface. So this is another modifier you are used to, and it's now being notified here. We can't really see much because we have a subdivided plane here, but if we switch to the wireframe mode, you can see that this subdivision node does what it's supposed to do, adds geometry. And if we now go back to solid view and we go to the edit mode, you can see that our base mesh is still here where we originally placed it. And if I take some vertices here and move them, they update in real time in the geometry nodes modifier. So that's the very basic gist of how the modifier works. So let's now delete these nodes, and obviously if you don't have anything going from the input to the output, you get an empty object. So you can just plug this back in there. And let's add another type of node. So from the point category we're going to add this point instance node and put it here in the middle. And now we also have an empty object here because we haven't specified an object for this field yet. So what this node does is it takes the geometry and it looks for points in the geometry, and then it instances an object or a collection. We're going to use the object. It instances an object to every point in the mesh, and then it hides the original mesh and then outputs the instanced objects only. So if we now give it this cube that we saved earlier, it's going to take this cube and it's going to instance it to every vertex location that we have in this mesh. So let's make things a little bit easier to see by making this cube a little bit smaller, like this. As you can see, it now has taken the cube and placed one cube in every vertex location here in the mesh. In this case, because we only have a simple plane here, this point instance node use the vertices of the plane to place the cubes. But there is this other node, this point distribute node, that will distribute points on the plane. So then if you use this node here before the point instance, it will actually use the distributed points instead of the vertices. But in this video, we're actually not going to use this point distribute node, so you can just leave it like this, because we want this nice geometric distribution. So if I now want to, for example, randomize the scale of these cubes, we get straight into the attribute stuff. Because with the attributes, you can modify the points that get fed into this point instance node. So the simplest of the attribute nodes is the attribute fill node. So let's add it here just for demonstration. Every point in this mesh, so basically every cube, has 3 default attributes: position, scale, and rotation. And if I type here scale, you can see that the scale of the cubes became 0. And if I drag this slider here, you can see that I can control the scale of the cubes. And 1 is the scale of the actual object that is being instanced. So what this attribute fill does is it fills all of the scale attributes here in this mesh with this one single value. And by the way, you have to do these attribute modifications before the instancing. So if I try to modify the scale value after I've instanced the cubes, it doesn't work. It has to be before it for it to function properly. So to actually randomize the scale, we can use another node from the attribute category here, which is attribute randomize. Surprise, surprise. And we can place that here. And if I now type scale here, you can see that we get a very nice looking randomized scale for these cubes. And we can do the same for rotation. So if I just duplicate this node with Shift D and type here rotation, and then increase this maximum value, you can see that we also get randomized rotations for every cube. Of course, rotation is actually a vector value and not a float like we have chosen here. And so this node is just automatically converting these float values to vectors. But if you want to control the axis of rotations, you can just change this to vector here. And this way you get control of each axis. So if I change these max values to 0, nothing gets rotated at all, and I can just randomize the Z rotation, for example. But in this example, we can just rotate every axis because it looks nice, and that's the rotation done. Now you might think that randomizing positions would be just as simple, just duplicate this and type position here. But as you can see, it doesn't work like we want it to, because these randomizer nodes don't actually take into account the original attribute values at all. It's just gonna overwrite the position attribute with a random vector inside of a cube of this size. So to just add a little bit of randomness on top of the existing position attribute, we can use the attribute mix node here. This node takes 2 attributes, A and B, and then blends between them with this factor here. The factor can also be an attribute, and these A and B values can also be attributes or floats or vectors or colors. And then there's also all these different blending modes. So it's a lot, but we'll make a simple example. So we'll take an attribute A and a vector B and then mix between them with this mix blending mode using a float as a factor. So our A attribute will be position. And then we also need to define the resulting attribute. So what attribute this node is going to modify in the end. And that will also be position. So now you can see that every vector position in this mesh is being blended with a vector of 0 by this factor right here. So if the factor is 1, every position is going to be 0. And if the factor is 0, every vector position will be the original one. That's how the mix blending mode works. It just replaces the A attribute with the B attribute by this amount here. But if we change the mix blending mode to add, it's not going to replace any of the original values. It's just going to add a vector to it. So now if we change the factor to 1, nothing is happening because we're adding 0 to the original positions. But if we now add, let's say 0, 0, 1, you can see that we can blend between the vectors being on the floor or a little bit higher. So why this is useful is because with these attributes we can also initialize new attributes that are not any of the 3 default ones. So what we can do is we can make another attribute randomize node, and we can type here, for example, position 2, and we'll make it be a vector ranging from -1 all the way to 1. So this is now initializing a new attribute named position 2 that has a random value for each of these vertices between -1 and 1. And we can now take that new random attribute and use it as this B input here. So we'll make it an attribute here and type here position 2. So now we're taking the original position and we are adding to it the randomized position 2 attribute, and the result is going to be mapped to the original position. And now if we increase this factor here, you can see that we start to get randomized positions on top of the original positions. And this looks very nice. We can use a value like 0.1 maybe. And that's how you can mix between an existing attribute and a new one. Okay, so the last thing we'll do in this tutorial is we're going to make the object controller that sort of displaces any nearby points. So we're going to add a new object. It's going to be an empty sphere. And for the plane object, we're going to add a vertex group. So just go here to the object data properties and add a new vertex group here. And we can call this proximity like this. And we'll go to the edit mode and select every vertex and assign a weight to it. The weight value itself doesn't really matter. The only thing that's important is that every vertex is assigned to this vertex group here. And then back to object mode and back to the modifier panel here. And we're going to add a new modifier that's going to be this vertex weight proximity modifier. And it has to be before the geometry node, so you can just drag and drop it there from this corner here. And the vertex group will be the proximity group we just created, and the target object will be the empty. You also want to change this proximity mode to geometry so that it actually looks at the vertices of this mesh instead of just the object's location. Now to see what this modifier is actually doing, we can disable this geometry nodes modifier for a moment and go to the weight paint mode. So you can see that wherever this empty object is close to the vertices of this plane, it will decrease the vertex group values, and outside they will be 1. And we actually kind of want the opposite of that, so that outside of the influence the weights would be 0, and inside of the sphere they would be higher. And we can do that by flipping these values here, 1 and 0, and now it works in an inverse way. And we can also make this fall off a bit bigger by increasing this lowest value here, something like this maybe. So now we can go back to the object mode and enable the geometry nodes again. You might be wondering why we don't see the nodes anymore, even though we have this plane selected here. And it's because we have this vertex weight modifier active here. You can see this blue outline. So if you just click on the geometry nodes modifier, you get the nodes back here. So now it's as simple as moving this over a bit, adding another attribute mix node here, and taking the position attribute as A and adding a vector to it as B. And the vector can be something like 0, 0, 2. And then instead of a float as a factor, we can use an attribute as a factor. And the interesting thing is that we can also use vertex group as attributes in the geometry nodes. So if we just type here proximity, you can see that we now get this nice effect where everything that's close to the empty object gets pushed up and everything else stays on the floor. We can also make the fall off a bit smoother by going here to the fall off settings of the vertex weight modifier and changing the type to smooth. So now you can see that it's smoothly interpolating between the values. And that's pretty much it. Now you know the basics of how to make some cool effects using the geometry nodes, and you know how the attributes work. And you also know how to use other modifiers in combination with the geometry nodes modifier. There's obviously a lot more to explore, but this should give you a nice starting point. I hope you found this tutorial useful. We watched The Soul by Pixar with some of my relatives over the holidays. It was a great movie, I really enjoyed it. And it sparked some interesting conversations about beauty in art. Some people didn't like the jazz music in the movie, and for others like me, it was really nice and I really liked it. And we started to think about why the same piece of art can be both beautiful and ugly to different people at the same time. You know, where does the beauty of an art piece come from? One thing that became clear is that knowing about the context of an art piece is often one thing that separates people who like it and those who don't. Knowing about the history of jazz and something about the theory or customs can result in more appreciation. Sometimes you sort of get in a certain genre or artist or piece, which then changes the opinion on it. Some difficult avant-garde jazz might sound completely nuts to you, but then if you got to know a person who plays it in a band and you go to a few concerts, have a good time, the musicians share some insights to the pieces they are playing, and all of a sudden you might see the whole genre in a very different light, just because of that context and personal experience. But then again, some people still wouldn't like it and still wouldn't find it beautiful. So it's not like the context and the background information is the only answer. There's gotta be something else to it too. So this interesting question rises up about the nature of beauty. Are good art pieces always objectively beautiful, and every person experiencing it just has to find the beauty in some way, which sometimes of course fails completely? Or is all beauty just a mental or social construct, and all art really is different physical forms that try to find a way to incite that subjective experience of beauty in the head? The first instinct for me is the latter option, that it's all just culture and some neurological stuff. But then why do flowers seem so beautiful to us, even though they don't have any reason to try to be beautiful to us? Flowers are only interested in attracting insects to pollinate them. Is it just a coincidence that their evolution happened to lead to a physical form that humans have always found extremely beautiful? David Deutsch had an interesting take on the beauty of flowers in his book The Beginning of Infinity, which by the way you should read, it's a great book. He thinks that there is objective beauty that flowers have found through evolution. They obviously needed a way to communicate their location to insects and to compete against other species of flowers to maybe attract a few more insects than some other flowers. And Deutsch thinks that since flowers and insects don't have any shared subjective experiences or methods of communication, the most efficient way just happened to be to evolve towards an objective metric of beauty as a communication tool, and that humans have then developed the same tools for recognizing visual beauty. He of course goes more into it in his book, so if you're interested, definitely do read the book. I don't know how believable I find that theory. Of course, he couldn't provide any measurable or replicatable evidence for it. It was just a postulation. But it was an interesting way of thinking that I hadn't really encountered before. It sort of tickled that part of the brain that goes, oh, that's a new way of thinking, which is always a nice experience. One more thing that comes to mind about beauty is that there's this Buddhist kind of view that all good and bad type of categorizations are completely fabricated inside human minds and egos, and that the real world just exists as a perfect wholeness, that everything sort of just is, and it's the human mind that then likes to divide things into good and bad, beautiful and ugly, important and meaningless, etc., etc. But taking that view at face value leads to art being more or less totally useless, doesn't it? if the idea is to strive towards a mindful, non-egoistic state of consciousness, wouldn't that make art totally useless in that state of mind? Or at least not especially beautiful compared to everything else, if everything is just a perfect wholeness. How interesting it would have been to get to ask Buddha about this. That'd be something. Maybe beautiful art is just our attempt to turn the perfect wholeness of the universe into more understandable language for human minds. And then it could sort of work as a bridge between the wholeness and our dark, dichotomistic minds. I don't know, but it's certainly interesting to think about. What do you think? Why can the same piece of art be beautiful to some and not to others? And is there objective beauty, or is beauty a human construct? Let me know what you think in the comments. I'd really like to read about your opinions. And that's pretty much it. Thanks for watching, and I'll see you later.